Science Friday is brought to you by Progressive Insurance. Do you ever think about switching insurance companies to see if you could save some cash? Progressive makes it easy to see if you could save when you bundle your home and auto policies. Try it at Progressive.com. Progressive Casualty Insurance Company and affiliates. Potential savings will vary. Not available in all states.
WNYC Studios is supported by Alienware.
Alienware's back-to-school event is the perfect time to score top gaming gear with incredible features and advanced engineering to go beyond performance. Start your Alienware journey with the Alienware 15 gaming laptop featuring Intel Core processors. Game, live stream, and multitask for hours on end. Pair your incredibly smooth gaming experience with immersive visuals and sound by saving on sleek Alienware monitors, headsets, and more. This limited time sale awaits you now at Alienware.com/deals.
Hey, it's Flora, and you're listening to Science Friday.
I'm just your backup in case you need. You guys ready?
You're listening to a group of shark researchers on a boat off the coast of Miami. They're trying to get a handle on how shark populations are doing by going out and meeting sharks in person. They just caught an 8-foot-long male bull shark using a baited buoy called a drum line. And now 3 adults are gently lying on top of it to hold it down on a semi-submerged fiberglass platform.
Pump on!
A pump keeps seawater flowing past the shark's gills so it can breathe. And over the next 15 minutes or so, they measure the shark, take blood and tissue samples, count parasites, do a microbiome swab, and implant a tag, all before sliding it back in the water. The team will do it again and again, all in a field day's work for shark scientists trying to answer how shark populations are doing. Catherine Macdonald was the lead scientist on that boat. She's a marine conservation biologist and director of the Shark Research and Conservation Program at the University of Miami. She is here to talk shark conservation and shark joy. Catherine, welcome.
Thank you so much for having me.
Thanks for being here. Catherine, that scene we described sounds kind of dramatic. Is that routine for you?
That's about 130 days a year of life for my team. And if we're doing it right, it's not terribly dramatic. We sample about 600 animals a year.
Wow, 600. And what kinds of information come from the blood and tissue samples, for example?
We can use those samples to answer a really wide range of questions, from questions about population genetics in species that are threatened with extinction to questions about what that tiger shark might have eaten in the last couple of days.
Yeah, okay, so what kinds of species are you working with?
We catch 12 species really regularly here in South Florida, and those are mostly going to be species that are coastal and subtropical. We see a lot of black noses, black tips, bonnethead sharks, which are a small member of the hammerhead family. We catch quite a few nurse sharks every year. We do see some of the species that you might catch on TV, the hammerheads, the bull sharks, the tiger sharks, but our more cold water friends like the white sharks are only passing through our area.
You said that you're looking at what they're eating. Have you found any surprises in their diet?
I'm having a good day when something doesn't surprise me on that particular day. But we did have a tiger shark vomit up a complete pig's foot on us a couple of years ago. And that one, I still remember.
Where did it come from?
My best guess is that some of our lobster and crab fisheries here in South Florida use pig's feet as bait. And so somebody dumping out their traps after finishing fishing probably left a treat that a tiger shark found.
What are some of the big questions that you're trying to answer? So what organizes your research?
At the largest scale, shark scientists broadly are trying to answer questions about what's happening to shark populations over time. And that requires something called fisheries independent monitoring, which is what we're doing. One of the difficult things about studying fish populations, if you're relying on data from fisheries, is that the regulations for those fisheries can change, or the amount of effort can change really substantially depending on the value of the fishery at a particular time. So
you mean so like the data's skewed if you're trying to catch something, you might see more of something?
So if you've been fishing within that fishery for decades with a net that has a particular size mesh. And then NOAA decides that to avoid bycatch or because it's going to be more effective, they want to change the mesh size. All of a sudden, your past data and your future data can't accurately be compared anymore because your method has changed.
Are there other ways to get at this besides catching them? Like, do people use camera traps like they do on land?
Yes, there have been amazing projects, including one called Global Finprint that used baited underwater cameras to study shark populations around the world. Increasingly, shark scientists are using drones to answer questions about sharks and their habitat use. But there are always going to be questions that you really need to get hands-on to try to answer.
You know, I keep seeing in the news and in drone videos on social media, sharks in waters, you know, across the country, from California to the Gulf of Maine to Florida, in these places that they haven't been for a long time. Is that the right headline, do you think?
Well, one of the things that's tricky about that is it's really hard for us to answer the question of whether they weren't there or whether we weren't seeing them. Because 20 years ago, even, if you went to the beach and you saw a shark, you'd get out of the water and you'd tell someone you saw a shark and they'd be like, yeah, okay, maybe. And these days there's people flying pretty high resolution drones at thousands of beaches around the country. And so there are questions about whether there are more of them or we're just seeing them and detecting them more often and in ways that are more definitive. But certainly in some parts of the country, we are seeing population recoveries and animals moving into habitats where they haven't previously been seen, at least not in recent memory.
Like where?
Massachusetts has certainly seen an uptick in its white shark population alongside an uptick in its seal population. If you recover shark's prey species, the sharks themselves are very likely both to benefit from that and to turn up where there's an easy meal.
What about in Florida? What trends are you seeing?
I would say that it's very species specific here in Florida. So we have some species where we are seeing population recovery, and this is a response to really good efforts at shark management by both federal and state authorities. And others that we're not necessarily seeing the population trajectory we would hope to. So for some really depleted shark populations, the rebuilding plans are really very long-term. It's after 2100 that we're hoping to see dusky sharks recover.
Wow, 2100. I need some shark wonder. Give me your favorite shark fact.
This is so difficult. This is so difficult. That's like asking an impossible question. But I usually like to tell people about how incredibly ancient sharks are. Sharks have been on this planet for longer than trees. But the one that really gets me is that they're older than the rings of Saturn. So sharks are an extremely ancient lineage of fish, and they've survived many mass extinctions. They're still here. They're still amazing. People often think that means that they're primitive, as kind of an insult. But in fact, the way that evolution works is if something works really well, it doesn't change. And so rather than thinking about sharks as a group of animals that haven't evolved, I think it's more helpful to think about them as a group of animals that made good design choices very early.
I mean, are they special? Are sharks special, or are they just like another cool fish?
You're asking the wrong person, because every cool fish is special.
Okay, well, what makes them special?
So there are a bunch of things that make them distinct, but normally the reasons that the public thinks about them as special is because of their predatory role in ecosystems, and for some species, their very large size. So if you ask someone to name shark species, I have a lot of experience with this. You're going to get answers that sound like white shark, tiger shark, hammerhead, bull shark, sometimes mako. And those are all extremely cool shark species, but they're actually also very extreme outliers in terms of what a shark is. So for all of our listeners out there, the average shark is 3 to 4 feet long, kind of brown gray, a little bit dumpy, and lives in the medium deep sea. So most sharks don't really look anything like those sleek, predatory animals that we tend to come across in documentaries or on TV.
And you love them for it.
I definitely do.
We have to take a break, but when we come back, we're going to talk about sharks and rays in unusual places. Don't go away.
WNYC is supported by Bayer. Every day in America, science delivers. Not just in the headlines, but in the moments that matter most. Science is a journey, one of curiosity, persistence, and progress. It's about asking questions, testing, learning, and improving again and again. Science delivers harvests that feed families, tools that help farmers grow more with less, and new ways to protect land for generations to come. Let's keep asking, keep testing, keep discovering, so science can keep delivering. Learn more at ScienceDelivers.com.
What if doctors could detect Alzheimer's before symptoms appear or treat cancer with unprecedented precision? On the new season of Tomorrow's Cure, the chart-topping and 2025 Ambie Award finalist podcast from Mayo Clinic, we explore how breakthroughs like these are already reshaping the future of healthcare. I'm Lindsay Seaver, the new host of Tomorrow's Cure, and this season I'm joined by leading physicians, researchers, and Mayo Clinic experts exploring everything from AI-powered diagnostics to precision cancer treatments. Follow Tomorrow's Cure wherever you get your podcasts.
There was a paper that came out of your lab earlier this year that got a lot of press. We gave it a little mention on the show, too. The tale of the remora and the manta ray. Remind us.
So, working with our amazing collaborators around the world, my PhD student, Emily Yeager, wrote a paper reporting that remoras, which are a symbiotic fish that often travels with sharks or mantas, are sort of popping up the cloaca, which is the all-purpose waste elimination and reproductive opening at the rear end of a manta ray.
Popping up, is that the technical term?
Well, we've called it cloacal diving, and I will say that that is the most diplomatic of the terms that we considered. But they're entering that cloacal opening and possibly feeding, possibly reducing their transportation costs, right? Because you're obviously avoiding water pressure pushing against you while you're in the cloacal opening. And possibly it's an anti-predatory behavior where you might be avoiding something scary that's happening on the outside.
Like it could be a subway car for that?
Yes, more or less. A transit opportunity with enhanced comfort.
I mean, does this tell you something bigger about the world? Or, I mean, it's delightful as it is. I don't think it needs to do any more work than it's doing. But is there any larger lesson from this?
I think that there may very well be. We know that remoras in general are open to eating poop. And so it's not just a transit opportunity, but with a snack car. But more than that, almost all of the literature around these relationships between remoras and their hosts assume that their hosts are unbothered by that relationship, that it maybe even benefits the host because some remoras eat parasites that might otherwise be kind of a nuisance. And this, in my lab, we talk about science as being forming and adding small bricks to a wall of knowledge. And this little brick contributes to a section of the wall that is asking questions about whether remora host relationships are really as problem-free for the host as has been previously assumed. If you see the video, it doesn't look like the manta ray is enjoying itself. And I can hardly blame it. So I think that this is a part of larger questions about if those remoras are entering the gill slits of a manta ray, the cloaca of a manta ray, if they're using their attachment disc in those spaces of more sensitive tissues. how much of a problem might that create for hosts? And, how should it affect the ways that we think about how those animals relate to each other?
I heard that you just got back from a shark and ray conference. What do shark and ray biologists talk about when they get together?
If you imagine just a room full of people who share your very niche, sort of strange set of interests, and how far down that rabbit hole you could go with 200 of those people, it's pretty much exactly what you'd expect. There's a lot of fish-themed clothing, although that's not 100% my jam, and a lot of fish-related conversations that, at least for me, are really energizing and inspiring.
Are you living your childhood dream?
Yes and no. I think child Catherine expected a lot less paperwork.
But you were the kind of kid who was like, I'm going to be a marine biologist, and then actually did it?
Yes. And I think more than that, I was the kind of kid who was dirty and outdoors and wanted to know why the crab was doing that. And the idea that you can spend your whole life answering questions like, why is the crab doing that, is to me one of the things that's really magical about science.
Okay, here's one of our burning why questions from the staff. Why are people always finding shark teeth? Like, are sharks constantly losing their teeth?
Yes, absolutely. This is such a great question. So sharks continuously replace their teeth throughout their lives, for some species as often as every 10 days. Every individual shark is producing thousands of teeth in its lifetime. And as one is dulled down and no longer is functional, it falls out the front and the next comes forward to take its place. That's going to keep everything nice and sharp and in working order. And so they're constantly developing replacement teeth in a little conveyor belt process. And its teeth are also the thing that fossilizes the best because it's cartilaginous. And so a lot of the fossil record on sharks is composed primarily of their teeth.
Oh, that's such a satisfying answer. Are there things that people can do to help sharks that we're not aware of?
When people ask how they can help sharks, there's a lot of answers that feel really obvious and not very useful, like don't eat shark, but most people don't. So the number one thing that you can do is help contribute to conservation of marine habitats more broadly. And so everything you do all the way upstream to clean up trash, to maintain water quality, to keep pesticides or fertilizers out of those streams and rivers ultimately benefits all of the marine animals that we care about. If you care about sharks, if you care about seahorses or manatees, because there's no shortage of amazing marine animals, think about the things that you can do to help with water quality wherever you do live.
I like the idea that we're all connected to sharks somehow, even if it's a few steps away. Okay, I have to know, Shark Week. Guilty pleasure? Rage watch? Neither?
For me personally, it's tricky because it is pretty much the one time of year that everyone is sharing my special interest, which brings me a lot of joy. But I would say I prefer the more science-oriented shark content, and that every now and then we end up down a road that I really wish we wouldn't go down. So for most of a decade, I couldn't give a public talk without having someone ask me whether Megalodon is real. And the answer is, 1, yes, it's a real shark, and 2, no, it's definitely not alive. We are 100% sure. For anyone who thinks that there's some scientific conspiracy to keep Megalodon from you, I would say a gigantic predatory shallow water shark would be on someone's cell phone video somewhere. And B, that scientists really are, we can't agree with each other about like basic facts about sharks. The idea that we could engage in a massive conspiracy to keep a shark from you gives us much more credit than I think we deserve.
Catherine Macdonald is a marine conservation biologist and director of the Shark Research and Conservation Program, part of the Rosenstiel School of Marine, Atmospheric, and Earth Science at the University of Miami. Thanks for coming on the show today.
It's been so much fun. Thank you.
This episode was produced by Charles Bergquist. If learning about cloacal diving is the kind of thing you appreciate, why not leave us a review on your favorite podcast platform? Thanks for listening. I'm Flora Lichtman.